this is a review of the SLTs 1 through 4. Just a reminder, there's basically 4 specific things that you need to do from SLT 1 to 4. You need to be able to construct a dilation, do it on a grid, and also just a regular piece of paper without being on a coordinate grid. You can determine the scale factor given something on a grid or in a regular just piece of paper, and determination if there is a dilation. So deciding whether something is or is not a dilation. And the fourth thing is finding the center of dilation. So these are the 4 objectives that we're going to kind of cover through these flip charts. Right? Feel free to pause anything, rewind, delete, and go back to it. But I'm hoping this really helps sum up all the things from SLT 1 through 4. So if I asked you to actually make a dilation, you need to know a scale factor. So I'm going to do a couple different ones. There's actually 2 different methods if you're not given a dilation on a coordinate grid. So the first one is, if you know the dilation is 2, all you have to do, that means that since it's positive, it's going to be on the same side of the center of dilation. So here's the center of dilation. Here are my 3 points. So because it's positive, I'm going to go ahead and use a straight line and draw a line that connects the center of dilation through each of these points. Okay. And then one more here. Okay. And once you draw the line, and I'm going to extend this a little bit. No, that's not very even. Once you draw the line from the point to the center of dilation, there's 2 different methods you can use to find out where the image of point L goes. One way is that you can go ahead and measure from here P to L. And then let's say that the distance from P to L is 2 centimeters. Well, now you know times 2 is 4 centimeters. So you go from the center of dilation, you would go out 4 until you got to a distance of 4, and you draw your line. And then from P to K, let's say this is 4 centimeters itself. So I know that from P to my new point would be 8 centimeters. So I'd measure from P to somewhere it'd be 8 centimeters. I draw my line, and then same thing with M. Let's say it's I'm just making this up, but let's say it's 1 centimeter or 1 inch. Whatever it is, you basically would measure now take that distance times 2, and you would get your new point. And you'd label them with prime signs, L prime and M prime, and then you would connect your points, and you would have your new triangle. That would be a dilation of this triangle. It would be double the dilation. Same thing would happen if it's like, if n was 1/2, it would just you'd cut each distance in half. So if this was 2, you'd go divided by 2. You'd go half of it, which would be 1. If this was 4, you'd go half of it, which is 2. And whatever this is, you go half of it, and then you would draw your new triangle. Same thing goes, same kind of process goes if it's a negative dilation. It's just the only thing that changes is instead of it being on the same side of the center of dilation, so before we drew a line this way, but if it's -2, it would just be going to the other side of the center of dilation. So when you go to draw your lines, you'd go from L to P, but you go through the other way. You go M to P and go through the other way, and you go K through P and go the other way. And then you basically do exactly what we did with the other problem. You would measure from L to P, and whatever it is, you would double it, and you'd measure from P. If this was 2 centimeters, you would go 4 centimeters this way from P. And then you would draw your new L. And basically, if you have a scale factor of -2 or 2, you're going to get the same size figure. It's just going to be on the other side of the center of dilation. If something is on a grid and you wanted to so here you can see the original and the pre-image are already drawn for, I'm sorry, the pre-image and the image are already drawn for you, and you can see that it gets smaller. So this is a reduction. So here you didn't actually have to perform a dilation, but in other problems you might have to. So say you got this original picture, and this was all on a coordinate grid. Well, if you knew the scale factor was, say, 2, you actually don't have to draw anything. You could actually just find out what are the coordinates of the points. Here there aren't any coordinates, but let's say the coordinates were 2, -3. Well, if you have a scale factor of 2, all you have to do is double or times 2 the x and the y, and you get your new point for -6. And then you would just graph that point. And whatever this was, say it was 8, 0, you would just multiply each by 2 and you get 16 comma 0, and that would be your new point. And you would do that for all 3 points on a coordinate grid. Here the question is, what is the scale factor? So here is a question, what is the scale factor? And in this problem, you are given it on a coordinate grid. So there are 3 ways that you can actually do this. The first way is to just find out what are the points of these 2 right here. So you can see that D started at 3, -3. And then the D prime, after the dilation, it's now at 2, -2. So if you wanted to know what the scale factor was, first of all, we could only do this if our center of dilation is 0, 0. So the first thing I'm going to do is I'm going to check. I'm going to put a line from G through G. It seems to go through 0, 0. I'm going to go D to D. Goes through 0, 0. And every time I connect these, it looks like it goes through 0, 0. So now we know that 0, 0 is our center of dilation. I'm going to leave one of those lines in. All right. So because we know 0, 0 is the center of dilation, we can actually just use the points. And to find out any scale factor, all you have to do is image divided by preimage. So in this case, our image was, it doesn't matter if you choose x or y, you'll get the same answer. So our image, our preimage was, I believe, 3. And our preimage was 3, and our image was 2. So image divided by preimage would be 2 over 3, which is our scale factor, 2/3, or 0.66. You'll get that same answer 2 other different ways, and you could do all of them. You could actually measure with a ruler from 0, 0 to G prime, and from 0, 0 to the original G. And you could take the distance of the original G from the center of dilation and divide it by the preimage's distance. So whatever the preimage's distance was would be from the center of dilation to this, and whatever the image's distance was, it'd be from here to here on the line. And then you would still do the image divided by preimage. The last way, and you get the same answer of 2/3. The final way you can actually, sorry about that, figure out what the that same 2/3, what the scale factor was or is you can actually just measure. Oops, sorry about that again. Let me get rid of this for a second. All right, so if you measure corresponding parts, so here's a corresponding part of the image. This would be that same corresponding part of the preimage. And if you measure that with a ruler and do image, the length of the image divided by the length of the preimage, you will still get that same 2/3. Now, if you're given something on a, just on a regular piece of paper, for instance, this is not on a grid, and I wanted to find the scale factor, you couldn't use the coordinate method. You would have to use one of the other 2 methods. So I can see that if you connect C through C and B through B, it connects at A. So we know A is the center of dilation. So if you measure, so one of the ways is to measure from the center of dilation to C prime, and then also from the center of dilation to the original C, which would be this line right here. I don't know what you get, but let's just say for just for this problem, let's say that from A to C, which would be the original, you got 10 centimeters, and from A to C prime, you got 5 centimeters. Well, you still can just do image divided by preimage, and you get 1/2, which would be the scale factor. You get that same answer if you measured corresponding parts, measured the image and the preimage, and still did image divided by preimage, the length of the image divided by the length of the preimage. That would still get you the same answer. The one thing that you got to be careful of, though, is whether or not the center of dilation is 0, 0. So, for example, here you can see that if you put a line from C to C prime, and D to D prime, they don't actually connect at 0, 0. So in this case, and in this case only, even though it's on a coordinate grid, you could not take the coordinates of C. So C is at negative 5, 0. And C prime is at negative 8, 3. Because the center of dilation is not 0, 0, you can't do the image. This would be the, right here, I believe, is the image. This is the pre-image. You can't actually do image divided by pre-image. Oh, I apologize. I switched those. This was the pre-image. This was the image. So I can't take the x-coordinate of the image and divide it by the pre-image. And the reason why is 0, 0 is not the center of dilation. You could only use the coordinates that way if that is 0, 0. Here, you would actually have to do one of the other methods. You'd either have to measure this and do image divided by pre-image, or measure the distance from the pre-image to the center of dilation and the distance of the image to the center of dilation and do image divided by pre-image. You could thank Mrs. Goldfarb for that. So a couple other things that we haven't gone over yet. One, dilations of a parabola. Remember, when you dilate something, it's the number or the coefficient in front of the x squared term. So if the scale factor is negative 1/2, you'd see a negative 1/2 there. Remember, the negative flips it, reflects the shape, and the smaller the number, anything between 0 and 1, the wider it's going to be. So a dilation of negative 1/2 would be wider, and it would be reflected downward. If you had a dilation of 8x squared, that would mean it would be skinnier. Here we talked about, right? So if you had to verify where the center of dilation was, remember, all you would have to do, and I'm just going to use without using a ruler, but you would use a ruler and you'd connect all of the sorry, that was a really, really sloppy way to do it, so I'll go ahead and actually do the okay. So remember, just connect the points, because when you dilate something, it's all based of a central location, and you can find that central location by connecting all of them to itself. So right here, I can see that the center of dilation is right here, and I also know, I'm not sure I could find out what the dilation is, but you could find out whether the dilation is negative or positive by looking at this. Both the image and the pre-image are on the same side of the center of dilation, so I know that this has to be a positive dilation. I'm sorry, a positive scale factor. Okay. So here, if it asks you to draw an image of a dilation with a center of dilation of 0, 0 and a scale factor of negative 1, remember, just by knowing that the center of dilation is 0, 0, you could just use the points. So C is at 1, 2, 3, 4, 5. 1, 2, 3, 4. So if you knew the scale factor was negative 1, you could just multiply negative 1 times x and negative 1 times y and get your new point, negative 5, negative 4. And you could just go ahead and plot that point on your coordinate grid and do that with all 3 points, and you'd have a dilation. I guess you can also, this would be silly to do in this case, but you can also go ahead and connect C to this 0, 0. And then remember, you can measure the distance. And then because it's negative 1, it's multiplying it by the distance by 1. So it'll be the same amount. It'll just be on the other side. So if this is 3 centimeters, you'll go 3 centimeters this way. Here we talked about, the only thing with using a compass that's a little bit slightly different than using, I recommend using a ruler, but if you really want to use a compass, you are more than welcome to. So when you use a compass, you would still do the same method. If you want a scale factor of negative 4 here, you would still connect D to P, which is, this is the center of dilation. you'd make sure you go through it, because remember, it's negative, so it's on the other side. You would just use your compass to measure this distance from P to D, and then you would copy it 4 times, because it's a scale factor of 4. So you'd go a distance 4 times as that. And wherever that ended up, that would be your point. So that's how you would use a compass instead of a ruler. And then we've already talked about how to do this one. So hopefully that helps you solve anything from SLT 1 through 4.